Yes. Okay, so welcome everyone, also from my behalf. My name is Vielen-Kallio. I represent Pre-Zero in the DecomTools project, but I'm also working for a consulting company ECHT in the Netherlands. And in the DecomTools project, we have been doing some testing with the wind turbine blades through pyrolysis. And this was one of the demonstrations, or actually the only demonstration, which is part of the DecomTools project. I will have a lot of pictures, because not most of the people might not know what pyrolysis looks like. We're talking about it, but there is actually quite a lot of misunderstandings also about pyrolysis. Most of the time people think that that means burning, and that is something completely different than what pyrolysis actually means. Just to give you some examples, so in this demonstration we had pieces of wind turbine blades. And this is the installation, the pyrolysis installation. So in practice, the pyrolysis process happens in here, and then there are cooling towers where the pyrolysis oil comes out. So what we got as an output from this process was the pyrolysis oil, which is quite similar to crude oil. So that is something interesting to remember. So it can be a substitute of a crude oil, a virgin oil. And the other outcome was, of course, the fibers, which here look more like a mess than glass fibers. But this is the outcome from a very practical point of view. But we also oven treated them in order to clean them into more white fibers. Not, of course, on a virgin quality, but still quite nice and neat. In these wind turbine blade samples that we used in the testing, there was both glass fiber reinforced plastics, but also carbon fibers. And the pre-cut pieces were from different parts of the blades, and this is also something interesting to keep in mind, because of course it's the resin and the organic material that reacts in the pyrolysis process, and this composition is different depending on which part of the blade you are. And the widths of these blade pieces were between 15 and 50 centimeters, and the length about 40 to 120 centimeters. And we did two different batches in the testing. And in one batch we had 35 kilos of wind turbine blades, and the other one was 44 kilos. So not laboratory scale testing, but a bit bigger size testing, but of course not yet full commercial scale solution. The original plan, there's always original plan, and then you recognize, oh, something doesn't work out. We were supposed to use a continuous pyrolysis process, but actually the installation that we had in mind originally, the problem was that because it's continuous, the reactor starts accumulating the fibers. Like I mentioned earlier, the fibers do not react in the pyrolysis process. So what would have happened is that the reactor would have been eventually full of these fibers, and then making the process ineffective. In this reactor, which you see here, there is a possibility to put 4 different cartridges. I will show you some examples later. But we tested only with one at a time, just to have a starting point as a pilot. The cartridges are about 50 centimeters to 200 centimeters in size, so that would be also the volume that we can fill with during the testing. We used approximately a temperature of 550 Celsius, and the processing time was approximately 90 minutes to run up and run down the process. This is the cartridge. So, like I said, it's approximately 2 meters long. And in practice, the pieces of blades were just put into the cartridge. We actually did run into another issue during this testing, because one of the blade pieces were too wide, and it got stuck in the cartridge. So that was one cartridge that we couldn't use. So, but that was luckily solved later. We were able to remove it. This is the place in the reactor where the cartridge is then placed. So the blades are in the cartridge, you put it into the reactor, and you can see that there is actually 4 places available. But like I mentioned, we used only one in this testing. So what happens in practice? We then seal the cartridge, and you can see that, I don't know if the other side sees, but so the gases, when it's completely sealed, the gases during the heating come out from here, and they are put, they are going through the reactor and then cooled down, and eventually the pyrolysis oil can be collected after it has been cooled down. There was no oxygen added, and that is of course the whole point of pyrolysis. It is not burning because there is no oxygen. There was a small amount of oxygen in the cartridge when we sealed it, but in practice there is no oxygen, so that's why it's also not burning, but gasification, and all those gases are then further processed. The non-reactive materials, the fibers, will stay in the cartridge, and all the gases are put into the cooling side. During this process, we received, of course, the pyrolysis oil, and that was further sent to another process, to the original process that we wanted to use. I will tell more about it. In total, from these 2 batches of wind turbine blades, we received 16 liters approximately. It's a big installation, so it's not full science or like full, really fully measured volumes. But we received 16 liters of pyrolysis oil, and this was the analysis about the content. So there was still 10% of water, but what is most interesting part of this is the 15% of phenols, because that is the excuse me, that is the amount of the volume that can be further converted into BTX, benzene, toluene, and xylene, and these are the normal chemical building blocks that are mainly used when converting crude oil, for example, to the chemical industry. So the market potential is huge because this is, for example, where materials like plastics are made out of. And actually, xylene is one of the materials that can be even used in the wind turbine blade industry. So all the phenols were converted into BTX, and this so-called heavies, which was 60%, relatively high, those can be further cracked also in order to increase the volume of the BTX. So a little bit about the market potential. The current pyrolysis oil market is 320 million euros at the moment. So the market potential for the pyrolysis oil as it is, even without the conversion to BTX, there is already a market. Now, the other output, the fibers. They look dirty, and this is not something that anyone wants at the moment. But what is also interesting to see that it was the process worked very well, so you can really see the different layers of the fibers. So we can see that the resin from between the fibers have reacted. And in total, we had 57 kilos of fibers and residue, but of course there was the char also. And what we then did was to check, okay, can we purify these fibers so that their quality is higher? Some examples, again, funny story. Our partner oven treated this piece. So where you see the A, that is the original sample we sent, and they put it in the oven treatment, and they called, is it possible that there is carbon fiber in this sample? So I think so, it is possible. yeah, we're putting it through the oven, and it just doesn't turn white, and we're expecting that it should be white. So yeah, it didn't turn white because it was carbon fiber. So there is also some learning there that sometimes you just don't push the process further and further, but actually it might be something else that is different. So sample B. This is also, on the left side you see the original sample, and then in the middle and on the right side you see how it turned out after the oven treatment. Like I mentioned, it's not the same quality as virgin fiber, but still there is applications that would be interested in these type of fibers. You can also see in the middle, this is a sample C, and they were just randomly picked from the big mess of after it came out from the pyrolysis process. So you can still see that not everything has reacted. So in the middle you see the pieces of balsa wood. Okay, then some conclusions. This has a potential to substitute crude oil. And I go a little bit back to the comment what Markus was making, that it's not always necessary to consider like, okay, how much energy do you put in, and what is the energy content of the oil that you receive? Because we need to look at also what are you making out of this pyrolysis oil. So if we go more to the direction of materials, and I think that was a comment that you also made, that we need to think, where do we compare our system boundaries, or where do we set our system boundaries? Because if we are manufacturing plastics, then what is the energy used to make plastics out of virgin crude oil compared to made out of this secondary raw material pyrolysis oil? So that is the challenge here when really diving into the sustainability aspect of things. In practice, we got about 27% of the mass of the wind turbine blades were converted into pyrolysis oil. Knowing that this is approximately the volume of resin in the wind turbine blades, so I would say that that's a good conversion rate. The yield of this BTX can be increased through the process optimization, because right now we used a lot of separate steps. So we used the batch process for the pyrolysis, and then we had additional step to convert the pyrolysis oil into the BTX, and then also the same with the fibers, that we did a additional oven treatment for them. So if we can, and these were all different locations. So we have been running the process up, and we have been running the process down in a very inefficient way. So this is where the optimization can be still done. So yeah, that would be my final point. Now, if we put things into perspective, for example, Siemens Gamesa is making their recyclable blade, meaning that the content of the blade is different than what we have tested here. It means that also this blade need a separate, different type of processing method. So it's a little more like a question that, do we start going into different directions, separate directions of how each blade should be processed? Or do we try to find something that is possible for all type of blades? Just some other example, ECHT blade have a very different design of a blade. Okay, they are not in the large market, but anyhow, there are also different type of blades available. ECHT Technologies are developing a different type of composite material. What is the effect on the end-of-life solutions where new type of materials come available? Policy changes, one of my favorite topics. What will happen when there is a landfill ban? So then it also means that the market has to pick up the new solutions and the circularity topic also for the blades. In the Netherlands, we are expecting that in the next tender for offshore, there will be a circular tender criteria involved there. So that means that already it's not about end-of-life problem anymore. It's about you really need to think about it already in the beginning, at the design phase, and you need to have a solution already before you put anything out there. Also, the recommendations that were given to the Dutch government and the RVO was that we should implement not only the landfill ban, but also that all the materials, including the wind turbine blades, need to be 100% used one way or another. We have a tendency to talk about recycling, but we should actually really start thinking about the narrative. It's not only about the recycling. Our strategies are much more extensive than just the recycling. But this has a huge impact, especially if there are new subsidy programs or whatever. It's always about recycling. But there's actually also other solutions that could be viable. We also talked about the uncertainty of like what is happening to these blades. And this is one of the things that will have a huge impact and a positive impact if we are having any kind of a digital tracing solution for the materials, so that the material passports or whatever would be actually available for the value chain by the time the material comes to end of life. Because then we are actually also initiating for different stakeholders to come up with new solutions. When we have reliable data, what is out there, it's much more easier also for the academia to pick up that data, and who knows what they come up with. Because right now it's estimations and modeling and different scenarios, but okay, what about if we would have reliable data? And I think that that's interesting also for the wind industry. You are basically outsourcing your R&D for free. So this is something that I think really should be implemented on a European level. Other recommendation that was given was also that the permit time would be extended to 50 years. And this gives an opportunity for the wind industry to come up with new solutions. So maybe it's not only the linear beginning and the end, but we start operating our wind farms the same way as, let's say, oil and gas industry is operating their refineries. That you have sometimes a break of just a maintenance break. Maybe that's something that also wind industry could do. I don't know. It just gives more opportunities to run your business in a new way, in a different way. And this is what I'm really interested in hearing more once it comes out, what is in the standard. Well, some people are working on it, that if it becomes a European-wide standard, then what does it mean in practice? This was my side of the story. Thank you.